Hi guys, today we're going to be taking proportions that we learned in the last lesson and using them for similar figures. Similar figures are figures that have the same shape but not necessarily the same size. And if they are similar, their corresponding angles are congruent, which means they have the same measure, and the corresponding sides are proportional. So you need to write all this down. I'm going to show you what I mean with these words in a diagram. Okay, number 2. Second slide, sorry. Part 1, corresponding parts of a triangle. So draw these two triangles with all these symbols in them first, please. And then you're going to write down all the notations. So when we say that two triangles are similar, two shapes are similar, we're going to say that triangle A, and first we use the triangle symbol, triangle A, B, C, is similar. That's the similar, the little squiggly line, that's the similar symbol. Is similar to triangle. Now A, see how A has 2 tick marks here? So that would go with T, which has 2 tick marks, similar to triangle T. And then B had 1 tick mark, same with U. So T, U, V. It just happens to be in alphabetical order. It will not always be that way. So this is one thing that we can say about this triangle, that they are similar. Another thing that we said in the definition is that the angles are congruent. That means they are equal. So angle A, that's the symbol for angle. It looks like an L kind of slanted. Angle A is congruent, means it equals angle T. They have the same measurement. And angle B is congruent to angle U. And angle C is congruent to angle V. They are equal. Also, with the sides, we said that they are proportional. What that means is that side AB, notice it has a 1 tick mark, AB, and we say side line segment like that, is proportional to TU, because it has 1 tick mark, TU, with a line segment. And it's proportional, equal, to line segment BC to UV, which is also proportional to AC. Now notice how I do this, A to C, so I went from 2 tick marks to 3 tick marks. TV is how I say the second one. You don't want to say VT. You don't want to go the other direction. So these are proportional. They can set up a proportion amongst them. And we could do the same thing with our numbers and set up a proportion and it would work. Okay, we're going to do 2 examples. So please draw these 2 pictures. They're saying if triangle ABC is similar to triangle DEF, so ABC, I'm going to use a highlighter here. AB is supposed to be similar, because I see AB in this order, it's supposed to be similar to DE. So I'm going to highlight those 2 in pink. And I know that because of the order, it went from A to B and then D to E. Then I'm going to use another highlighter. I'm going to use green. B to C is going to be similar to E to F, like that. B to C is similar to E to F. And then, again, the bottom, and I'll leave those 2 unhighlighted. Find the measure of side BC. So we don't know that side, BC. I'm going to put an X here. So since we know the sides are proportional, we're going to set up a proportion. I'm going to do AB to BC, so I'm going to do 12 over X equals 16 over 10. Notice I'm doing the pink side to the green side. 16 over 10. You get 120 equals 16x. Divide both sides by 16. And you're going to do 120 divided by 16. And you get 7.5. So x equals 7.5. Okay. You could have also have done 12 to 16. 12 to 16. So I went from my little triangle to my big triangle like that, equals, and then x to 10. And you will still get the same answer because you get 16x equals 120, which is our original thing here. All right, the second example we're going to do involves these two triangles as well. So the second one says, if they're similar, find the measure of DF. So this time we want to find the measure of this here. Okay, so I'm going to compare two sides that I know. I know that 12 and 18 here from my little triangle. So I'm going to do 12 goes with 18. 12 over 18 equals, and that was from my little triangle, so now I'm going to go to back to the big triangle, equals 16, the pink, to x. 16 to x. So when you do your cross products, you get 12x equals, you do 18 times 16, and I get 288 divided by 12 gives me 24. And that would be the measure of side DF. All right, so let's do some indirect measurement. Hold on, it's loading. Here we go. Okay, indirect measurement is loading. Allows you to use the properties of similar triangles to find measurements that are difficult to measure directly. So, what I mean is,
call the office.
we have a large building here, the John Hancock Center in Chicago. And it casts a shadow. So what we're going to do is we're going to just draw a little shadow here. Here's my shadow. A shadow that is 257.5 feet long. Okay? And at the same time, a nearby tourist, here's my tourist, casts a 1.5 foot shadow. If the tourist is 6 feet tall, they want to know how tall is this building. Basically, you're making two triangles. Here's your triangle if you just do this. And we can do that because it's at the same time. It has the same degree of the sun coming down and hitting. So we have two similar triangles, and what we're going to do is set up a proportion. So we're going to write the shadow of the girl to her height, 1.5, to her height is 6. Equals the shadow of the building, because we did shadow to height, shadow of the building is 257.5, and we want to figure out the height of the building. Now there's many other proportions you could have done, that's just the one I happen to choose. Do your cross products. 6 times 257.5 is 1,545. Divide by 1.5. X equals 1,030, and we're talking about feet. And there you go. And that's it for today. We'll do more in class. Have a good one.